all my aspiring mathematicians. Today I am going to discuss with you the Rational Zero Theorem. What is the Rational Zero Theorem? The Rational Zero Theorem states that a rational zero of a polynomial is in the form of p over q, meaning that it is a ratio of p and q, whereby p is the factors of the constant term and q is all the factors of the leading coefficient. When we are given a polynomial, it is usually in the form like this. And you will note that a sub 0 cannot be 0. Also, we need to identify our constant term and also our leading coefficient. Since the rational zero is usually the ratio of p over q, since a sub 0 is the constant term, we need to find the factors of the constant term, and that would be our p. So p is going to be all the factors of our constant term. And q is going to be all the factors of the leading coefficient. Our constant term is a sub 0. This is our constant term. And our leading coefficient is a sub n. Now, since we have this, we can now note that we can be given any example, and one thing you must do is first list all the factors of the constant term and then list all the factors of the leading coefficient to therefore write down the list of your possible rational zeros. Now, one thing I must say to you is that when you're doing this, you have to be very careful. There will always be a plus or a minus number. So now let's get right into the problem and show you an example. So our first example that's given to us here is f of x is equals to 2x cubed minus 3x squared minus 2x plus 3. First thing we're going to do here, we are going to find our ratio of p over q. So we are going to now write p over q is going to be the factors of 3. So we have to write the factors of 3, and it's going to go over the factors of 2. We are going to list the factors of 3. So p over q, and we're going to list the factors of 3, which are going to be plus or minus 1, plus or minus 3, and then the factors of 2 are plus or minus 1 and plus or minus 2. So we only have 2 factors on the top, and we also have 2 factors on the bottom. So the next thing we need to do now, we need to write these as possible factors. So the first one is going to be plus or minus 1. The next one is going to be plus or minus a half. And the next factor is going to be plus or minus 3. And the next one is going to be plus or minus 3 over 2. Now the next thing we need to do now is that we can go ahead, and once we choose one of these factors and test it, we can then go from there and apply the synthetic division to find the other factors. So the first thing I'm going to do, I'm going to test the first one, which is going to be -1. So let's test our -1 first. We can apply the factor theorem to find out if 1 is one of our 0. So we can simply substitute wherever we see x for 1, and we are going to substitute everything here. 1 to the third power is 1, and 1 times 2 is going to be 2. minus 3 times 1 to the second power is 1. This is going to be 2, and this is going to be plus 3. F of 1 is going to be 2 minus 3 minus 2 plus 3. So these two numbers, the 2 minus 2 is going to be 0, and the negative 3 plus 3 is going to be 0. Or if you didn't do it that way, you know that 2 minus 3 is going to be negative 1, and negative 2 plus 3 is going to be positive 1. So in this essence, you notice that f of 1 is equals to 0. Since f of 1 is equals to 0, therefore that means that x minus 1 is a factor of the polynomial. We can apply the synthetic division so we can factor out and know what is left. So we have our 1, which is going to be here. Then we will put our 2, negative 3, negative 2, and 3. We don't have a missing term here, so we don't need any 0 placeholder. So we are going to bring this down, which is going to be 2. 1 times 2 is 2. We're going to put it here. Negative 3 plus 2 is going to be negative 1. 1 times negative 1 is going to be negative 1. Negative 2 plus negative 1 is going to be negative 3. 1 times negative 3 is going to be negative 3, and this is going to be 0, our remainder. Now, because we have 0 as our remainder here, we can now state that this is going to be our number, this is going to be our x value, and this is going to be our x squared values. So we will end up with 2x squared minus x minus 3. You can go ahead and further factor this out using the grouping method, or you can go ahead and use the ARC method, because in this trinomial you will notice that your a value is greater than 1, so you can use that method to factor this out. But if you don't know how to use any of those, you can go ahead and apply the synthetic division again and factor this out further. Go back and watch my video on using the synthetic division method to factor out a polynomial. Now let's go ahead and further factor this out. We can apply our synthetic division to this, and we will now have 2 right here. We'll have negative 1 and negative 3. So we are going to use negative 1. So if I use negative 1 here, I can bring this down. This is going to be 2. Negative 1 times 2 is going to be negative 2. When I add these, I'm going to get negative 3. Negative 1 times negative 3 is going to be positive 3, and I end up with 0 here as my remainder. So therefore, negative 1 is another 0. And we can also state that the other factor is going to be x plus 1 in this case. So we have our number here, and this is going to be our x value. So now we have 2x minus 3 that's left. Because we know that we have the factors of x minus 1, and we also, and that's from this, and we also have the factor of x plus 1, our other factor would be 2x minus 3. And so our zeros now would be negative 1 in this case, comma 1, comma, you have here 2x minus 3. So therefore, because you have 2x minus 3, your factor here is going to be 3 over 2 for your other 0. So this is 3 over 2 because you have to set this equals to 0 and further factor it out. So you have 2x minus 3 equals 0. You bring that negative 3 on the other side, so you have 2x equals 3, and therefore you divide by 2 on both sides, and you will end up with x equals 3 over 2. So that's why you have 3 over 2 as your other 0. So basically, the rational zero theorem is simply a way of listing the possible zeros, and from your list of possible zeros, you can now further factor it out to see which one are the actual zeros. But in most cases, sometimes you don't need to factor out everything to find it. Once you have listed the possible zeros, that is what you are focusing on. So in this case, we are given the polynomial x to the third power minus x squared minus 14x plus 24. Since the highest exponent in this polynomial is to the third power, we are going to end up with 3 rational zeros. So let's get right into it. So we are going to list the factors of 24, because that is going to go on top first, and we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then we're also going to have plus or minus 8, plus or minus 12, and plus or minus 24. So these are our factors of our constant term, which is 24. So now our leading coefficient here is the invisible one. We just normally don't put it there, so it's just simply an invisible one. So we just simply have plus or minus 1 under the bottom for the factors of the leading coefficient. Simply just one number we have, okay? List all possible zeros, and they are simply, all these numbers is going to go over 1, so it's simply plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, because we have to do all of these over what number we have here, which is going to be 1. Alright? So we have plus or minus 6, plus or minus 8, plus or minus 12, and then we also have plus or minus 24. These are the possible zeros, and we are only going to end up with 3 because our highest exponent here is 3. So with this being said, we can always first test 1. If you test 1 and it doesn't work, then you go on to the next number. So I'm going to test 1 right now. Use the synthetic division method, or I'm going to apply the factor theorem. And if you don't know how to apply the factor theorem, you can go back and watch my video on how to apply the factor theorem or the remainder theorem. So let's get into this. I'm going to test it with 1. So I'm going to write out all my numbers here, and I'm going to use the synthetic division to test it. So bring down your 1, and 1 times 1 is 1. When we add this, we're going to get 0. 1 times 0 is 0. We end up with negative 14 here. 1 times negative 14 is negative 14. And we have a remainder here. So because we have a remainder off the top, we know that 1 is not a possible 0. So you cannot use 1. So we can go on next, and we can also test negative 1. So let's test negative 1, and I'm going to apply the factor theorem to test negative 1. So we have negative 1 to the third power minus negative 1 to the second power minus 14 times negative 1 plus 24. So f of negative 1, this is going to be negative 1. Negative 1 to the second power is going to be a positive 1, but you already have the negative here. So you have that, and then you're going to get a positive 14 over here plus 24. So f of negative 1 is going to be, this is negative 2 plus 38. Therefore, I can see off the top right now that negative 1 is not a 0, because we end up with 36. In order for it to be one of the possible zeros, f of negative 1 would have equal to 0, and therefore you could have stated that one of the factors would be x plus 1. But no, it is not. So we can cross out the plus or minus 0, because no, those are not one of the factors. So let's continue. We are going to test 2 as one of our possible zeros. So let's set this up. 2 is here. We have 1, -1, -14, and +24. So we bring down our 1. 2 times 1 is 2. We add this, we are going to get 1. 2 times 1 is 2. We add this, we're going to get -12. 2 times -12 is going to be -24. And our remainder there is 0. So since our remainder is 0, we can now state that 2 is one of the possible zeros for this polynomial. And also we can further state that x minus 2 is a factor of the polynomial. So we will now be able to identify what is left. So we have our number there. This is going to be our x value. This is going to be our x to the second power value. So we will be left with x squared plus x minus 12. We can factor this out because this is a simple trinomial, and if you don't know how to factor a simple trinomial where a is 1, you can go back and watch my video on how to factor a trinomial when a is equal to 1. So we are going to use the factors of -12 and the factors of -12 such that when added is going to give you a positive number here. Because this is a negative number, one of your factors have to be negative and one of the factors have to be positive. We can go straight to the shooter and know off the top that our factors of -12, that is going to give us 1, which is our middle term, are going to be 4 and -3. So we write it as 2 sets of binomial x plus 4 and x minus 3. Those are our factors. And so we can further state that the factors of the trinomial are x minus 2, x plus 4, and x minus 3. And we can further now, so these are the factors. And now we can further state that the zeros are 2, -4, and +3. I hope that this video has helped you tremendously, and now that you know how to find the possible rational zeros by listing all the factors of the constant term over the factors of the leading coefficient, and then you list all your possible rational zeros and you test them. Please go ahead and practice, because math is all about practicing, and if you have a phobia for math, you should always be practicing at least 25 minutes per day to get over your phobia and to gain better understanding of the topic. So thank you for watching. Please share and like my videos with others around the world.